here we go. We got two more properties to learn. The commutative property and the associative property. Commutative property first. That is basically dealing with the order of things. Okay? The order. What it says is that I can add any numbers I want in any order. Doesn't matter how many. We'll just do two for an example here. So if I have a number A plus some other number B, I should get the same result if I take B and then add A to it. For example, 4 plus 5 equals 5 plus 4. They both equal 9. Well, guess what? There is another operation in mathematics that we can do in any order we want, and that is multiplication. So, if I have A times B, I should get the same result if I do B times A. And we pretty much know that to be true. Let's take 3 times 7. That should be the same as 7 times 3. And sure enough it is. So that checks out. Alright, the associative property often gets confused with the commutative property, but this property deals with not the order, but grouping. I can group things in any order. Okay, so let's use three numbers. Okay, you can work with 4, 5, 6, 7, 8, 9, 10, doesn't matter. Well, let's do 3. Let's take A plus B plus C. A plus B plus C. Now, that's the same order, but what I'm going to do different this time is I'm going to add these two numbers together first on this side and then add C. And on the other side, I'm going to add B and C together and then add A. Let's see if we get the same result. Okay, so let's just take 3 plus 4 plus 5 equals 3 plus 4 plus 5. But I'm going to group it different. I'm not going to add them that way. I'm going to add these two numbers first, then add 5 to it. So I get 7 plus 5. And here I'm going to add these two numbers together first and group those two numbers. And that's 3 plus 9. Well, sure enough, it still works out. 12 equals 12. Okay, guess what else it works for? You guessed it, multiplication. Multiplication also works. I have A, B, C equal to A, B, C. The left side, I'm going to multiply A and B and then C. Okay? And then on the other side, I'm going to multiply B and C together. And then multiply it by A. Should still get the same result according to the associative property. So let's find out. We'll take those same numbers, 3 times 4, parentheses, times 5. That should equal 3 times the quantity, the group, 5, 4 times 5. Well, here we go on the left. We have 12 times 5, and here we have 3 times 20. Well, 12 times 5 is 60, and so is 3 times 20. So, once again, commutative deals with order. You can scramble it all up how you want. Associative deals with grouping. I can group a set of numbers, but it only works for addition and multiplication. You cannot subtract in any order, and you cannot divide in any order. You cannot group subtraction in any order. You cannot group division any way you want. So how can this help us? Well, what it really allows us to do is make problems simpler, and simpler is better, right? So let's take a look at a few examples here, quickly, using the associative and the commutative properties. Here we go. Let's try example number 1. Let's try 14 plus 7 plus 26 plus 13. You could certainly add those straight across, try to do it in your head, but there's a simpler way. You can do it in your head, you don't need a calculator. Well, first thing I'm going to do is move things around. Okay, I can move those numbers around, it's all addition. Commutative property says so. So I'm going to take 14, I'm going to add 26 to it. Okay, and I'm going to do 7 plus 13. Okay, why did I move it that way? Because I know in my head now I'm going to group some things. And you're probably doing this all in your head anyway, but this is the reason why we can do it. It's these properties that allows us to do this. Okay, so I'm going to group those two numbers, I'm going to group those two numbers, and I know that 14 and 26 makes 40, and I know 7 and 13 makes 20, and I can easily add 40 and 20 to get 60. Okay, let's take a look at another one. Example 2. How about multiplication? 2 times 7 times 10 times 3. Yeah, you can do that left to right. Probably do it in your head. But let's use our properties. Try to make it simpler for ourselves. Let's just swap the 7 and the 10. Let's do 2 times 10 times 7 times 3. Well, and then I'm going to group them. I'm going to group these two, and then I'm going to group those two. That's associative property. 2 times 10 is 20. And 7 times 3 is 21. That I can do pretty simply in my head. I know when I multiply by 10 or 20, I need to put a 0 at the end. Double 21, I get 420. Is there another way to do that? Sure. Maybe there's an easier way. How about 2 times 3 times 7 times 10? Okay? And then I'm going to group it like this. And I get 6 times 70. Sure enough, that's probably easier. 6 times 7 is 42. And you just add a 0. Boom, 420. Easily done in my head. Okay? It makes problems simpler. Let's try one more. Alright, let's try one with, yes, you love them, fractions. 3/4 times 7/10 times 2 2/9. Well, it's all multiplication, so you know the associative and the commutative properties will work. The very first thing I'm going to do is I'm going to see that mixed number, and I know when I multiply fractions, that mixed number has to be turned into an improper fraction. We know how to do that. We learned that back in 6th grade probably. Here we go. 3/4 times 7/10 times 9 times 2 is 18 plus 2 is 20 over 9. Okay? Very good. Well, first thing I might want to do here is just maybe group these. I'm going to look at that. So notice that I can cross reduce the 10 and the 20. Okay? 10 divides 10 one time. 10 divides 20 two times. How do I multiply fractions? Straight across. So I got 3/4 times 14 over 9. Alright, not too bad. Alright, so then I'm going to cross reduce again. This is a 1 and a 3. I can divide both those 2 by 2 and get 2 and 7. Straight across, 1 times 7 is 7, 2 times 3 is 6. Okay, so let's do a real world application problem here. It's not going to be too challenging a one. Keep in mind that the story problems you're going to have are going to often model what we did. So here we go. Trinity made a list of trail lengths to find the total miles she rode. Find the total miles Trinity rode her horse. Well, look at our table here. We got the name of the trail with how many miles she rode her horse on that particular trail. So if I want to find the total, we all know the total means add them up. So do we need to go jump to our calculator right away because it's faster? I don't know if it's even faster. Okay, this should be done in your head. When you look at it, here's what I'm going to do. I'm going to put them in the order I want right off the bat. Okay, I'm going to go 4.25 plus 7.75 plus 6.50, or just 6.5, plus 9.00, which is just 9. Okay, then I'm going to group them. Say, okay, I'm going to group them. What is 6 1/4 plus 7 3/4? Well, the decimals add up to 1. So I got 1 plus 4 plus 7, which is 12. And 9 and 6 is 15.5. 15.5. Okay, I can add those two in my head pretty quickly. 12 and 15 is 27, and I have a half. We need to label that miles. Okay, so if all that wasn't enough, let's play a game called Find the Value of X and name the property used to help you learn those properties. So here we go. Let's make a quick table. Quick one. I know you like the sound effects. I don't even know if we'll use all those, but here we go. Let's extend that a little bit. Yeah, perfect. Okay, here we go. You might get something like this. 3 equals 3 plus x. Well, first thing you need to do is find the value of x. What's going to work there? Hello, people. 3 plus 0 is 3, right? So x is 0. So let's just replace that. 3 equals 3 plus 0. Okay, that's a true statement. What property says that? That is the additive identity. Nice. All right, here's one that everyone gets wrong. It says it's impossible. Sit and think about that for a second. How can I multiply a big number times another number to get a smaller number? Very simple. You guys know that. Multiply by the reciprocal to get 1, right? So 5 times 1/5, x would be 1/5 in that case, equals 1, right? You just put that over 1, cross, reduce, boom, boom, boom. There, now you see it. What says I take a number, multiply by its reciprocal, and get 1? That is the multiplicative inverse. Beautiful. There we go. 3 plus 4 equals 4 plus what? 3? Yep, you're right. 3 plus 4 equals 4 plus 3. So x in that case is 3. Okay. What says that 3 plus 4 equals 4 plus 3? That is the commutative property. Says I can add in any order. Sure enough. And let's do this one. I'll throw a fraction one in there because you love them so much. X plus 5/8 equals 2 plus 5/8. Well, what does x have to be? 2. 2 plus 5/8 equals 2 plus 5/8. Says the exact same thing on both sides. What was that one? That was the duh one. Reflexive. And that should wrap it all up. Thank you very much.